but we'll get it going in the next few minutes.
Okay.
Are we live on the tube,
on YouTube?
Facebook,
Facebook is
Instagram?
not working, so I don't know
Okay.
why, but so just YouTube and Instagram today.
So Instagram's been patiently waiting. I think we had like 10 people leave already, but thank you for joining us. Here's the rest of the team. We got Fu here this
Hey
week.
guys, today's topic is 3D models. We want to kind of touch base with everyone on maybe you have some questions on how 3D models work with CNC relating to software and the workflow. A lot of people always ask us like, hey, does your machine cut 3D? Does it do 3D? So what is a 3D? What's a 2D? Can it do it? Can it not do it? So we're gonna just go over some of the stuff real quickly so you guys have a better understanding of how 3D works. And we'll talk about 3D printers and what kind of software people use for 3D printers, the free ones, the paid ones, and see, what are your options out there. Maybe we could start with Joel, who is our tech support guy, and he's also a mechanical engineer. He's efficient with SolidWorks and also VCarve.
Ooh, okay. We'll get to the questions and the comments after this intro too. So yeah, great thing is Joel is the most proficient when it comes to design since he's the one that's had professional training on it. The rest of us we're kind of learning ourselves. So Joel, how about you tell everyone a little about your experience with 3D design work?
So from my experience, what I was using most of the times was SolidWorks and also Inventor and also a little bit of Mastercam. So as far as the 3D modeling, I would say we use CAD and also CAM systems. So the CAD is supposed to be the computer aided design. So for the CAD, it's supposed to help assist with the creation, modifications, and also supposed to be for accessing many of the parts and the creation of that specific part. I would say CAD is usually for high detailed engineering drawings, and it would help with 2D drawings and also 3D models as well, and it's used throughout the whole entire process. So I would say as for the CAM, the main difference, CAM has to do with the computer aided manufacturing. So let's say for instance, in short, if you want to place it on a CNC machine, you're going to use a CAM software. Both could be integrated as one, but I would say very few have both of them. So CAD will allow you to do the detail drawing, while CAM, if you have a certain tool path, what it will do is that it will do a numerical code for it, and then after it will put the instructions so that way you could have a G code and it drives the machine. So many of the times, if let's say you create a certain tool path, let's say a simple profile, then if you want to insert that G code into UCCNC, that's when you'll be using the CAM system, which is the computer aided manufacturing, to help assist that. So I would say there's many differences with 3D modeling softwares. There's one such as, I would say, Blender, which is a 3D graphic software. So that one, I would say many people use that for, you see movies, video games, and also I would say for architecture. But the main difference is that if you want to make a certain product and you want to engineer it and you want to have each of the measurements, I would say it's best suited to using the CAD systems such as SolidWorks, Inventor, and there's a lot of them. Even Tinkercad, they have a lot of those softwares that would help with it.
Okay, so let's walk through the whole process. So from start to finish, if I'm trying to make a cabinet door, for example, in your mind, like what's the steps someone would need to take from using the designing from the physical side versus the software side?
Okay, so for the physical, what you'll need to do is, let's say if you want to cut a specific material, you'll do measurements on it. So you'll just measure the width, the length, the height, and so after you get an accurate depiction of what you're going to cut, The next thing you'll do is that you'll do the job setup. So you notice in Vetric and also in Aspire, we set the XY datum position. So that's supposed to be the reference point for that when you're gonna cut. So if you select the sensor, say for instance, you would do the drawing. So the drawing, you need to have accurate measurements for it. So I would say with SolidWorks, Inventor, and also Vetric, you can adjust many of the lines. There's such things like AutoCAD, where it'll be very difficult after you make a certain line that you can adjust it. The good thing is that you can just set it, and then after you could set the scale, so you could change it throughout. So let's say for instance, if I just drew a line and it's 3 inches, in AutoCAD you would have to delete it, and then if you want to change it back to 2.5. With these other ones, the CAD softwares and CAD softwares, if you want to adjust it to like 3 inches, you can do that. And also you could, I would say in SolidWorks, you could extrude it, which is for the 3D aspects. Vetric, the complication that comes with it is that it's limited. You could do 2D and you can import 3D model for STLs, but Aspire you would have the capability of making 3D models.
Okay.
So that's like
what do you mean by extruded?
So extruding is supposed to raise or shrink the height of the model. So let's say you just made, let's say, a box. If you extrude it, what you're doing is that you're basically raising it, so that way you can,
So you like stretch it kind of thing?
So it's basically like stretching.
You just like drag it?
Yeah, you could increase or decrease it. And you could also do cuts. So let's say, for instance, if you want to cut it to a certain height, you could do the same thing with that.
So extruding is only specific for 3D files, is that correct? Or can it be also a term used for 2D?
So for the extrusion, you would do that for 3D modeling. So when you're making a 3D, you would extrude it.
To clarify there. Okay. And I think we had some questions in the chat on Instagram. Big Mike was asking, how hard is it to convert grayscale? I think he meant grayscale to a 3D workable file. How hard? So I'd say if you're using software that we provide, like VCarve, taking a grayscale image and then taking that off a high resolution image, you can find that anywhere online. You don't even necessarily need to have the, I'd say, Photoshop skills, right? You can import that from something that you find on Google, import it into VCarve, right? And then you can even bitmap trace that, right? The neat thing is on our lasers that we use with the OPT, in the CNC plugin, there's the grayscaling for laser. So you can get near, I would say, realistic grayscale engravings from the laser, right? So that would be my say there. It's very easy. The plugin allows you to simply click, drop, and load, and then basically the CNC creates the G code for the laser to engrave that. Now for a 3D working file, do you have any input on that?
So what I've seen with 3D, sometimes people could import certain things in, like, I would say Blender, so that way they could just increase the model. But as far as doing it 3D, I would say that I haven't had as much personal experience doing it with grayscaling a 3D model, but like you were mentioning, we did it with the lasers with CNC.
Okay.
You could do it in Aspire, right? Grayscale to the 3D model creation.
I believe so.
Yeah, you could do it with Aspire, but you probably have to mold it.
You would have to start sculpting.
Yeah, Aspire is kind of good for importing like any image. The more complicated, you'll get a lot of noise. But if it's like a grayscale, you'll probably get the dark or light parts become a raised model, and then you can go in and molding like digital molding. It's like sculpting digitally. You can basically flatten, smooth. You could put indents in it. You could raise it, but it takes some time. It's literally like sculpting with your mouse and the tools, and I think that's kind of the basic way, and that's pretty much the main difference between Vectric Aspire and a VCarve Pro. VCarve Pro, you would take a 3D model from another program like Blender, Fusion, SolidWorks, something was already created, a model, you download it online, already created, and you would import that into VCarve and basically carve it out on your CNC or import it into a 3D printer. Aspire, you could take a picture of a person's face and just import it in, and you could click a button, it'll convert it into a 3D model, but obviously it's not going to look that perfect, or it's going to be nowhere near perfect, and you would have to go in and kind of mold the face and make it look like somewhat presentable. So it's literally like digital sculpting, but it's good in the sense you can kind of start with a picture essentially and turn it into a 3D model. So that's kind of the powerful tool in that sense. But I would say the simpler the picture, like if you took the person and photoshopped out the background, for example, and it was just white, it was like a PNG and it was just the person, and then you imported that into Aspire, it can just create the model of the person. So it's kind of useful for that kind of stuff. And then Fusion, SolidWorks, I think is more advanced,
Yeah, it
right?
is.
For in terms of 3D, and Blender, it's just like 3D focused. So I would say it's kind of better for like 3D printing. Those kind of softwares would probably be better for 3D printing, where you could really get more down to detail, like Joel was saying. You can stretch it. It's probably easier to use than Aspire. Aspire is mainly, I think, for more so CNC stuff, and then the other ones are more, you could use it for mostly for 3D printer, I would say.
And I'll say another thing with Fusion 360 and SolidWorks that's the main difference between Aspire is combining parts together. So using SolidWorks and Fusion 360, let's say for instance you want to see if two parts could combine together properly, you can do that with the
It has the mechanical engineering aspect, right? You could fit parts to see if the tolerance is good.
Yeah, you can make parts parallel to one another, and then you could assemble them together. You could even see if the holes will fit with one of like the rods. I would say another thing that's also pretty interesting with SolidWorks is it has the capability of doing simulations. So let's say, for instance, you have a force going on top of it, you could see what would happen. So let's say, for instance, if it weighs too much, it could tear off the product. It will show that. It will show the strains on it and the stress.
That's cool. Like that would be cool for 3D printing. Like if you're trying to make something, two pieces that want to fit together, so you could test it in the software first, right? Does it tell you if it's too big or too small? Like it'll show?
If it's too big or too small, you could see that.
Okay, that's cool. All right. Does anyone have any questions about anything?
It's in the chat. I think Tony Cuts asked about what is VCarve? VCarve. What's VCarve? Okay, so the most easy way to break it down is, as they mentioned earlier, with VCarve. VCarve was a software that was designed by woodworkers, specifically for woodworkers. So if you're someone like me, my background is not like Joel's. I never got professional training. I learned on the fly. And the most I ever touched when it came to design software before we did any of the CNC or any of the automation, the most I ever touched was probably Paint, Microsoft Paint. So I was not knowledgeable on any of extruding. I had no idea what that meant. I didn't know anything about 3D, two-dimensional planes, working in digital. So for me, when I picked up the VCarve software, learning it and navigating it, once I knew what buttons did what, I was able to picture in my head exactly what I wanted to do with that specific tool assigned to it. So if you try and jump right into a software like Fusion 360, which is very great and all because they have like very high-end graphics, you probably need a more powerful computer, like a gaming computer, versus if you just use VCarve, you can load that up on a very standard Windows-based PC, and you'd be fine. The rendering with the simulating and all of that is not as complex, but you do have the three-dimensional editing capabilities. I'd say it's a little more basic when you're talking about Aspire. Aspire is like the top of the line software for VCarve. The great thing about the VCarve though is it's designed specifically for you to be able to import three-dimensional files like STLs or even a two-dimensional DXF that's already been created for you. So you can go to someone like Joel, he can create that file for you, and you would simply import that into VCarve. And then from VCarve, you would use that to specifically assign a tool for your CNC, specifically like your quarter-inch end mill, for example. And that specific end mill would be that tool path you're setting in VCarve. So you don't need to know any of the manufacturing, like G coding, anything like that. That program is doing it all for you. And you don't need all the extensive school. You don't need to go to 4 years of college specifically on how to design digitally. You can learn as you go, and there's a lot of support features. There's a community behind it. There's YouTube videos. Also here on our team here, we're always helping each other, bouncing ideas. How do I do this? How do I do that? And we work around it. So a lot of our members on the i2R CNC owners group also share a lot of their projects and their process on how they create their files. But for me, I like to find a design I like, import it directly into VCarve, and then just put it to the post-processing. And then from there, it goes right into our software on the PC, which is the UCCNC, and that's what's controlling it. I think there was another question on something about bits I saw.
Where are you looking?
I'm on my phone here too. What bits should I use for doing 3D carving? Who wants that one? You want that one, Fu? Or
3D carving, mostly you need a rounded bit, so tapered ball nose is good. They have different sizes. Tapered just means the tip is very small and it starts to get larger as you go up the bit. But tapered ball nose, I like to use the 1/16 tip. That one is pretty good. That will get you pretty decent details on most of the 3D cuts. And yeah, you pretty much use that for pretty much everything. And then unless it's very tiny, small details, then you might need to use something a little bit with a smaller tip. But 1/16 tapered ball nose is probably my favorite bit that I use. And if it's a larger project that you don't need a lot of fine details, then you could even use like an 1/8 inch ball nose to get certain things done, certain curves out. If you're making guitars, you could probably just use a 1/4 inch ball nose, and you could still do nice curves on a body, for example. So it just depends on the details, I would say, mostly.
Yeah. Okay. Joel, you have input on that?
Another thing as well I just recommend is you'll have to do the roughing pass as well. So you could just remove some of the excess material before you do the finishing pass.
Yeah. Okay. Yeah. The roughing. The great thing about the roughing is a lot of the customers that we have usually jump up from the 1 horsepower spindle to the 2 horsepower spindle that we have on the B series, because the roughing, you do save time with the larger tooling in some cases. So with the roughing, I like to use the 3/8 inch a lot of time, and that will shave off about like 20 minutes on my roughing if I'm doing a big piece. So that's one of the great benefits of using a larger bit, since we're talking about bits. What's going on, Rhodes PC 3D printing? How's the printer doing? It's doing great. We've still got those offers for you to reserve a 3D printer, like the one back here.
Yeah, you can show. I think it's actually, if you send us a DM now, you should be. Well, I think we're still setting it up, but if you send a DM 3D, you should get a message with a link to basically lock in your slot for a 3D printer. Only it's $105 to lock in your spot, and you're gonna get basically $900 off the printer. lead time is about 3 months, but you get a heavy discount for a really great printer. So we're only giving about 10 people the opportunity to do that. So if you guys are interested, just DM us 3D on Instagram, the words 3D, and you should be getting information about it. Yeah, the 3D printer is super easy to use. Show you guys, this has a touch screen right here, SD card, you could boot it up. This one has dual filaments,
Guys on YouTube aren't gonna be able to get as close up,
but
but
it's
you'll
super
watch the
easy. Like
replay.
you all you gotta do is take a 3D model, put it into your, download it from somewhere, or create it if you're into that. And they use a software called Ping Slicer, and essentially it just shows you a preview of the platform, and you literally just drop the model in, size it up to whatever size you want, do some settings, and they have like predetermined settings too, so it's very user friendly for new people. And you just save it on the SD card, you pop it in, you kind of set your Z level, similar to a CNC, and you hit go.
yeah, you can also connect it to your Wi-Fi, so you don't have to use the SD card too. So that's another neat feature that the printer has.
Okay.
What can you make on the 3D printer that you can't on a CNC? That's from That Then That. Cool
Well,
name.
you could make a lot of whole shapes, basically. CNC is 3-axis, so you're limited in the sense to basically like the height, for example, because you have a Z clearance. 3D printer usually has higher Z clearance, so you could print like a, I don't know, like a head of something, or I think Sunny made a what did you make, like a headphone stand?
Oh yeah, I made an Iron Man headphone stand for
Yeah.
the headphones, and then we're actually in the process of trying to 3D print the laser mounts for the attachment that go onto the front of the spindle. So we're gonna try that out. Joel actually created that. Actually, since the topic today is also software, how do you want to go from talking about what you did with the file that you already had for cutting the aluminum mount?
Yeah.
And then what software did you use to create the STL file for that so that we could print it in the 3D printer later today?
Yeah.
Yeah, walk us through that.
So for the whole entire procedure, what I did was that since we had the measurements previously on our Vectric software, I just downloaded that one as a DXF file, and then afterwards I imported it into SolidWorks. So since I had the measurements, the next thing I did is that I created it as a part, and then you could have the 2D drawings. So I selected the plane, and after I selected the plane, I just draw out the lines. And I would say in SolidWorks you could do either or. You could just make it on your own, or you could just trace the lines, since Vectric already has the same things as the measurements going. So what I did afterwards, after I made the part, I just checked each of the dimensions to check if everything was accurate, and then I just extruded it. And then the next thing I did was that I tapped the holes. So we have, say, at least 6 holes that we have to tap, 2 for the 6 watt and then 4 for the 15 watt. And then the next thing I did was I just exported it as an STL file, so that way he could use it for the 3D printer.
Yeah, and then once Joel got me that file, I basically just imported it into the software that you can download with the 3D printer once you get it, and you slice it. And the neat thing from there is I think it'll take about an hour and a half to print. It's a little mount there. And with the 3D printer, they have filaments also that are combined, so they have like metal type of materials. With the PLA is the main plastic that you're using with the filament being the material, versus on the CNC you're using a stock that you're gonna cut away. Tony said, I want to make a gun. I said, okay.
Illegal 3D print.
Yeah, that's great. I mean, there are things called ghost guns out there that I think they're legal now, but we do have customers that are making gun stocks with their executive 4x4 machine and supplying that out to an Olympic shooting team. So that's one cool thing. Since we're talking about guns, Rhodes PC. I'm currently making a big mouse robot kind of thing and have a 3D printed head, body, and arms, and then use the CNC to make the mechanical legs. Awesome. That said, don't do that, Tony. Don't make guns. All right. And then yeah. So I've already got your order down there. PC Rhodes. He does custom computers. So it'd be great to think about what other projects you can make with the CNC in conjunction with the 3D printer. And another thing that we have customers doing is they're printing their own dust shoes with the printer, and they actually seem to work very well. For me, I'm still trying to put together the CNC and the 3D printing process so that we could do some really cool projects together. If you have any ideas on how you would do projects with the 3D printer and CNC, put them in the comments, DM us, let us know, and we can probably try to do it here, replicate it, work with you on setting up a process too. I think did you have something to say? No? Okay.
Is there any other questions?
Easy decision to upgrade. Alright. So we're talking about, what else did we want to talk about? Going back to software, right?
Anybody use Fusion 360?
So on the topic of Fusion 360, you can use Fusion 360 with our machines. There's just a few setting changes. There are a couple clicks, and then the V-carve 100% is the most easy way to streamline your process. And when it comes to SolidWorks, I think Joel's the only one out of the three of us that really works with SolidWorks. That one, you can still design your projects in SolidWorks, but then you would still need a middleman like V-carve to post-process that project and put it into G-code for the UCCNC to understand and cut. That's my understanding right now. And then what other softwares are popular that you guys are using? I think you mentioned Blender. I think Blender is specific to just 3D slicing, right?
So I think with Pat, what he did was with the mountains, he started to make it and mesh it. So he would have the heights. So there's a specific height in a location, and Blender could automatically do that. So what he was doing was that he was making an STL with that, and then after he imported it, the typology.
Okay. When you say mesh, there are people out here that probably don't know what that means. What is meshing? What do you mean by that?
So the mesh and vertices, it's basically the points of that way. It's everything is mathematics, so it's making out the shapes.
Any type of shape, any type of contour, like.
Yeah, for that one, it was basing it off of Google Maps.
And Blender is free, right?
Yeah, that one's that one's free.
Yeah, so Blender is completely free, so you guys can just download it and mess with it.
Yeah, if you want to test out V-carve, you can get the free trial on vetric.com, and then once you test it out, you can always purchase it on our website, i2rcnc.com. They're based in the UK. We're a licensed dealer for them here. The only thing you can't do with the trial is actually export those files to cut. So that's one thing to remember. It's all only software based on your computer. You won't be able to make actual real projects. I think on the 3D printing side, if you're talking about like those Blender softwares, or there's another one you mentioned. I think was it Katia? Katia?
Oh yeah, Katia.
Is that? I think that's also specific to 3D modeling, right?
Yeah. So the ones that have STL files, you can export. Those ones are perfect for 3D printing.
Yeah. Okay.
Michael Cadigan, what software works with digitizing probe?
UCCNC actually does work with that. There is a way for you to install a 3D probe, but then you still have to set up the UCCNC settings to work with it. We have guys like Stony CNC out in Ireland who are using the probes, and they are setting them up with UCCNC and our i2R machines, A series, the executives, to do the probing. So it is a possibility. We don't offer that as a default package right now, but there is some customization you can do on your end with your machine there.
Okay. Anybody else has any questions?
I think if you're not, also one helpful thing is if you're not already, or if you don't want to make your own 3D projects from scratch, I want to avoid people thinking that you have to understand how to make your own files, which you don't. You can go on Facebook, you can go on Etsy, you can buy pre-made 3D files for a couple cents. Most of them are free. Some of them are $30 depending on how detailed they are. So you can go online, simply just grab them and download it. We also offer files projects that we've made to customers that get our machines, and one of the most popular videos have been like the Medusa one, where I show you how to go on Tinkercad, for example. I think that one was Tinkercad when I made it like 3 years ago, and I found that file, imported it right into VCarve Pro, even VCarve Desktop will do, and then you're just setting the stock size, the material, and the feeds and speeds, and the type of bits you're using. That one was a simple 2-step with your roughing process and then your finishing process, and we actually have a customer right now who's making those projects, and I think he's doing pretty well with those.
Cool.
And I think we need to get better at looking at the other audience too, on the other camera, because we're always focused on the Instagram guys, even though we love you guys. But yeah, YouTube, we gotta make a better effort at talking to you guys.
The
and
camera's
Facebook.
like too far away.
We'll come up with a better situation. Yeah. Oh, Stony CNC. We were just talking about you. We were just talking about Stony CNC. Welcome. They just joined. Maybe we'll bring them on as a guest one of these days if they wanna wake up earlier on the feast. Vince Williams, how's it going? Move ASCII. Matthew Coy, just shout out to everyone here. Jay Berg Customs, Michelle Maroche. Sorry if I ruined that.
Afritech also
Any
use
other?
Blender. I lack skills to make models that I can conceive in my head and can find free STL files that are good, not skulls. So do you find Blender usable? Like, is it easy to learn? I actually never really used it, but some of the guys here have. Is it hard to like create a skull, for example?
I think
or not?
Pat was the one that's mainly focused on Blender. I think. What about you? Have you made
as
anything?
for Blender, I was just trying to do the same thing with the mountains.
The topography.
Yeah, the topography.
Yeah.
As far as that, I guess it's a little bit complicated, but as long as you start watching some YouTube tutorials.
What about like a
should be
cup?
helpful.
Is a cup easy to make?
I would
in
say
Blender.
the way that I was doing it, I was just following the tutorials.
Oh,
But
okay.
I would say as far as the cup, it's kind of like sculpting. So the same thing as Aspire, how you can make certain 3D models, you could do the same thing in Blender. And
Right.
also 3ds Max, another one that's also the same.
Okay. Yeah, I mean, as we mess with 3D printers more, I think we'll probably start messing with that more.
Yeah.
Or maybe you could make some stuff in SolidWorks.
I see what certain people like to do. It's also with SolidWorks, Blender. They will take an image, and then afterwards they will start sculpting around that image. So let's say, for instance, if there's a human face, they'll start with the eyes, and then afterwards they'll work their way back. So I guess it's similar to the one in Aspire where you do bitmap tracing, like you were mentioning, and
Yeah.
after it's working on each part.
They have that in SolidWorks?
Yeah, in SolidWorks you can import images, and then afterwards, let's say you have an airplane that you're making, right? You could take certain parts of that airplane, then you could, let's say you're just trying to trace that certain part of the wing. You could then afterwards adjust that part, so you can make it into a measurement. So you're like, oh, I want this to be 50 like millimeters.
That's pretty cool.
Yeah, with SolidWorks, yeah, definitely. I think you do need some training on SolidWorks, and you do need to know what you're doing. So when I mentioned when I first started, I didn't really know much about software, so I was learning on VCarve, and it was actually Stony CNC over there. They're the ones that were doing all the stuff in SolidWorks, and then whatever they were doing there, they would export it, and I would put into VCarve, and then I would machine it. So that's a process there in itself. If you know someone that's really good at creating those files, you could just have them do it for you, and then, like I mentioned, go online too, and then just learn the VCarve.
How long did it take you to learn SolidWorks?
I'd say with SolidWorks, it's like in drawing or doing any skill, you have to have a bunch of experience on it, and then afterwards, what you'll do is that you keep training yourself on it. If you get a little bit rusty, it won't go away. It's just that you need to do a little bit of
practice.
Yeah,
I guess.
Well, that's something they teach you in mechanical engineering school, right?
Yeah, they do.
So is it like throughout the whole 4 years, or is it like a 101 class and then like?
So the way that it worked was that there were certain semesters, and they will dedicate on using CAD software. So let's say one would say, oh, you want to use Mastercam, and they'll teach you how to use Mastercam. And then afterwards, they'll have another semester using SolidWorks. So they get you using or practicing a bunch of parts, and then assembling those parts together. And then afterwards, you could do certain classes like simulation. You could test it out, and vibration. So there's a bunch of classes that work around that same 3D modeling.
Yeah, if you guys are using any other software out there that we didn't mention, put in the comments. Let us know. We can help spread that word too, and whatever's most popular.
Keith Fleming is waiting for i2R 8 from Stony.
So Keith, that's the Europe side. Stony, where's the i2R 8 for Keith?
Stony, hurry up. It's the
glad
boats.
I'm glad you got an 8 though. That's a good size.
You'll get there.
I'm sure they'll get you up to the executive too. And in a year from now, you'll get the executive. We've got a little, more people joining. Alfin CNC, Honor Balamir. Shout out, guys. Okay. Any other questions in the? Let's take one more question. We're almost running out of time for today's episode. Any other questions specific to VCarve, 3D, the machines, CNC, 3D printing, anything at all? Put in the comments.
Okay, I guess that about wraps it up for today. If anybody else has any questions, just feel free to send us a message and we'll respond.
Yeah, sorry you guys joined late here at the end. Appreciate you guys signing in right now, and we're about to end the episode. But yeah, get here early. Usually on the Instagram, we get on live maybe like 30 minutes before the other feeds.
Yeah, replays on YouTube, so you could always go to our YouTube to listen to the replays.
Okay, guys, and stay tuned for our A series. It's about to hit our warehouse soon, and also we got the W series coming. You could do those pre-orders. Contact me, sales@i2rcnc.com, or put it in the DM on Instagram. Follow our YouTube channel. We're also on LinkedIn, TikTok. It's all i2rcnc. We've got a lot of content that we're pushing out, and always don't hesitate to let us know what you would like to see. Also, if you're interested in coming on as a guest, talking about your experience, whether you're a hobbyist, side hustler, business owner, educator, whatever it is, we're more than happy to bring you on. All right, thanks for signing in with us. We'll see you next week. Don't forget, every Thursday we're here at 12 o'clock Eastern.